A cyclogan is made of two discriminator and two generator networks. The discriminators dx and dy in this cyclogan are deep convolutional neural networks that see an image from domain x or y respectively and attempt to classify it as real or fake. The general structure for both of these discriminators is the same, and it looks like this. This network sees a 128 by 128 by 3 image as input and passes it through a series of strided convolutional layers that downsample an image by a factor of 2. In this diagram, we have 4 total strided layers, but you can add or decrease the number of layers as you see fit. Through these 4 strided convolutional layers, we see our image go from 128 to 128 to 64 to 64, all the way to 8 by 8. The first layer has a ReLU activation function applied to its outputs, and the next 3 have batch norm and ReLU functions applied to their outputs. Then we have one final convolutional layer. This is not strided, and you'll have to set the stride and padding accordingly for this layer. The job of this last layer is to act as a fully convolutional classification layer. So its job is to take in the outputs from the last convolutional layer, and it should output a single value, the logits of our discriminator. To define the discriminators, you're expected to use the provided helper conv function in this cell. This should look familiar from the last lesson on deep convolutional GANs. This function creates a strided convolutional layer and an optional batch norm layer. With a stride of 2 and padding equal to 1, I'm assuming that you'll use a kernel size equal to 4 to downsample each input by a factor of 2. So using this helper function if you want, it will be up to you to define the discriminator class. You only have to define this one class, and then later we'll use it to instantiate 2 different discriminators, one for the X image domain and one for Y. To complete this class, it may help to use the above image as reference. This image also includes recommendations for increasing the depth of the convolutional layers as you go, starting with a depth of 64 and increasing by a factor of 2 for each convolutional layer. In fact, the starting depth is set as the convdim, the one input parameter of the discriminator class. I should also note that we're not applying any activation function to the last layer, and we'll talk about this later when we go over defining the discriminator losses. I should also note that we're not applying a sigmoid or any other activation to the last layer, and we'll talk about this later when we go over defining the discriminator losses. Okay, so try to solve the discriminator class on your own, and next I'll go over one possible solution.